Hello everyone. Today we're looking at the command Metaballs and the way of how it can create those very lovely kind of shapes that can later be used for buildings really well. To just quickly showcase what they can do, for example, here we have like a certain points that we had set up, and those points are movable back and forth. And the good thing about it is we have this very nice way. Actually, let me delete this here as well. We have this very nice smooth definement of those lines, so we can really shape it the way that we want. So to explain, let me delete this one here, of how we got it this way, it actually works this way. There are, wait, let me show this in Paint actually. So we're having basically points that are defined somewhere, and then those points will be moved up, but not always in the same rate. And then those moved up points have basically points as well, and in a certain length. And when we have those points defined up there, we can, let me put that one here as well, maybe a second one. We're having those lines, and those lines basically, they have a certain strength to it, and only when they go very big they overlap, and when they overlap they form one big one. And that's like one command in Grasshopper that you can use, and it's really useful. And what results in here, when we have those things differently charged, they might create certain overlap areas and create bigger nice areas that we can use for it. So there are certain ways of how you can start this, obviously, but in my case we're going to make it hopefully as simple as possible in a way. As you can see here as well, you can always rechange it and change drastically of it. So let's start with a new Grasshopper file, and we're going to create those points very simply. Create a point, multiple points, put them wherever you want to have them, like this maybe. And actually I used it different before, but I think maybe we can use it like this. So we use the STL command, use the starting point, the direction will be in Z, so up, and the length will be a number of series. So yeah, let's get some numbers in here, like this, like that, and the count number has to be the number of points that we actually have. So we do it with list length. List length, and with that we have a certain amount of points. Gonna move it also, they're very tall. Let's get this back a little bit. Okay, so now we have our differently sized vertical lines, and they're all different, as you see here. Maybe we can make this more smooth as well. So yeah, now we have our differently sized things. So the next thing we're going to do is we have to divide this curve by a certain distance. And the distance in this case, well, it doesn't really matter what it would be, but it would be like the length of each floor, or the height of each floor in a way. And as you see, the higher the distance, the distance doesn't really matter, but like the dependent on the distance we have a different amount of points. So as you see in our thing, in our panel, the lists are differently sized. That's very important to keep in mind as well. So next thing we're going to do is we use the there is under, I always forget where it is. Well, anyway, it's called Metaballs. Go Control Alt Click. It's on a mesh triangulation, and then we get our metaballs. I like to use the custom one because you have more force of what you want to do over it. So yeah, here you have the points, and we also need to have the planes set of how they are. The way to do is, for example, to take the longest, or we can also just use the plane. Use a plane XY. We need to construct this plane over on each of those things. And then we have the planes. Now we also need to have the points, and the points are here as well. And then the heaviness of the charge of those points. Okay, I think now charges. Okay, so we need to graph this. No. Yeah, what we also can do, we can make a series of those charged points and the amount of points, because the charges need to be set correctly. Actually move this here. Can use the length of this and the step of that. And now we have each of our things. The problem you see right now, they're overlapping, but they're not really joining together correctly. The thing is, because of this, actually this error myself, because right now we have so many planes, and what we just need is just basically the highest amount of planes that are there possibly. So a way of doing this, for example, right now we hear the longest list is always like the last one. So if we can, for example, tree item, and we can use the path, or wait, we can also use a different one as well. Actually, that might be more, tree branch might be more useful, yeah. And then we're gonna use under param viewer, and we have the param view of this one here. And now we just all need this final, the longest one. So we're going to use list item, and we're gonna reverse it, so we're having the last one in here. And we're taking this as the path, and we're taking this as a tree, and now we're going to use those as our plane here. And we need to graph this as well, so there might be together where this is not correct. Let's see what got wrong here. Actually, we might actually need to flip the matrix as well, because basically we have the points each set up like 1, 2, 3, 4, 5, 6, 7, 8 till 10 over here, but we need them together like that they're down here together. So we need to flip the matrix. Can put this here, put this there, and I think by that we can also change some other parameters that we don't need anymore right now. So at least now we have our points set up, but they're not in the right height. So what we're gonna do is now is we're going to actually, let me get this back here. Does it work? No, it doesn't. Let me see what's going on here. It's always interesting in Grasshopper when you trying to figure out what is happening, what isn't. Okay. So the Z direction is correct, as you see here always. It's like the higher ones are in there. I think the best way is actually to just move it up by the Z direction, take the distance here and multiply it by the amount that we have. I think that's like the most cleanest way of getting there. So we have now the distance of those things multiplied by the amount of thing that goes up, and it should result in 29, and I think it's actually 19.8, and I think this actually corresponds to the highest number we have here. No, not really. So I might have mistaken one thing actually. So no, this would be the, so wait, no, we need the series like here, like this, and we need to have a, yeah, we need to create, we need to create a series, and the steps would be the distance, and the number would be that, and now we should be, and we take the start value as well from this one, and let's see, this doesn't really look that correct, because, so wait, the distance, the maximum length of each of those things is 22. So because it's 22, we need to divide it. So we have a correct, we have the non-correct amount of points that go up, because there is a, so they're going to be, the list length would be 11, and it would go up by 11. So we can take the last tree branch, take the path, and we can take yeah, we can actually take it from here, actually from this directly here. Then we take just the list of the last one, and we're going to use list, no, actually this will show us a, no, it will actually show us a graph, it's true, but so now we have the param here, we have the amount of them here, and I think what we need to do, because we have the list length, so we have the list length is 11 here, and we need to flatten this one and to reverse it, or like we just need to use the last of those ones here. Then we have one item here which is 11, and this 11 we need to move up by the amount of things that we have here. So the series and the count would be 11, the step would be the same with the distance of it, and the start will be non-existent, like this, and now it needs to move up into Z direction like this, and now we have it correctly. They're all connecting in the right way. And what I also wanted to do, because right now the charges are all like the same, let's say. You see, when we, for example, want to move a point around, it will always be at the same thing here at the side, and this is not something that I want. But a way to counter that is, for example, well, we can either, well, we have the values of the points, and the values of those things might be too, like, not enough. So we could actually like change them in a way. So let me actually see of how it will work if we're gonna use this one here. And decrease the amount, the general amounts. Okay, I think we still have still like a slight bend to it in a way, so the charges are basically different, but we want it to be so that it's like more drastical. And I think we can just achieve that by multiplying them all by a certain amount. Let's try to put this here. No, it didn't really work at all. What would also be possible is to, because right now we have the count number of them, right? And we have the charge amount. And maybe in order to, actually, wait, if I would, I can maybe reparameterize them as well, for example, and then use a graph to help me out with that. So we can just remap the numbers, and it will remap them from 0 to 1. And we can use the boundary of those things here. And now we can use the graph, and we just do like a parabola or something. And at least something's moving, but not the way really how I want it. So I have to multiply it again in the way. And I think this will achieve us better results, hopefully. I won't really. I wonder, there might be a certain, I think maybe I made a little mistake here. But anyway, so here you have the thought process in Rhino and in Grasshopper, and sometimes you get like small hiccups and you don't really know exactly what to do. And I think it's also always very interesting, so you can kind of like figure out exactly what you were doing wrong. But actually, I think a good way actually to do it, it might be that we just flip this one as well here, like back to it, and then we might be, what's the data's getting out of here? Well, that's not correct. But if you're gonna use this one here, flip it first. Actually, this one I'm just trying out. I don't really know what I'm doing at the moment, but I think it always can make it very interesting in a way. Or it doesn't really work at all. Yeah, but like I definitely recommend it to try out the ISO curves of it, the Metaballs. It's a very useful tool. As well as, for example, if you want to continue using it, you can really well use it for example. Well, let's get some stuff here a little more together. Since now you have those curves here, you can very simply extrude them in the direction that we had in the beginning. And we can simply, if we put this into here, we can simply use it from there, and now we have a those each, it would take a while because it might be those ISO curves not that smooth in a way, not that clear. Oh yeah, actually that's what I did with the last one before actually too. So we have a more defined curves. You can just simply rebuild them, and by a certain degree that's like higher than 1 degree, not count, and the count might be actually quite high. And if we now extrude as well here, so now you have like each of those single layers, which is quite cool. And then you also can, for example, if you use the boundary surface, you can make like the top of those things everywhere, and maybe you wanna have it as well on the bottom and on the top. Then you can move it up as well in the same amounts. Put it over here, and yeah, well, it's actually, it might be a little bit laggy, to be honest, because it has to recalculate it sometimes, as you see. But yeah, well, I have to like look into it close enough of how I made the previous one in the first place, because it's something I want to personally also continue on doing and get more into this topic. But yeah, and now you can simply again put your stuff in and look around how it is, and make maybe also like a little rendering from it, if it all works out. So yeah, thanks for watching. It was a little bit of a not so good thought process of it, but I will definitely get more into the Metaball thing in the future, because my future project has a lot to do with it, and those kind of like connections of those things and how exactly